So injection can happen in a lot of ways. So one of the, like, even in like security orchestration environments. So like maybe like a security operations engineer wrote a security orchestration automated response. That's SOAR means. Wrote a script that will repeatedly call an API to get logs to go into a centralized logging environment, a SIEM. So, you know, maybe you trust your MSSP or whoever, you know, built this API or, you know, what have you. But if you aren't actually escaping that stuff, you can have, I guess this is technically supply chain compromise, but it, you know, it's just a trusted partner compromise in that sense. So, so you want to, even if you don't think this code, even if your code is not outward facing, even if it's not a web application, you definitely want to make sure you know what you're taking in and you're escaping it and parsing it safely. And there's a lot of different. Generally, the advice is you don't want to reinvent the wheel. There's already existing functions in whatever. There's already a library for cryptographic stuff, but for any of this safe escaping for whatever language you're using. So you definitely want to use one of those functions instead of trying to create your own parsing, because and create like a block list of like various characters or substrings that refer to like some form of injection, because it's a fun game to try and beat the block list and get it. So this is one of the factors that you know, it contributes, or sorry, one of the factors that contributes to insecure design is the lack of business risk profiling inherent in a software system being developed, and thus the failure to determine what level of security is required. Insecure design is really broad and represents different weaknesses expressed as missing or ineffective control design, but this is very vague and you can't really test this, right? But the general idea is that insecure design can't be fixed by perfect implementation, whereas secure design can still have issues, vulnerabilities. But insecure design isn't designed to defend against specific attacks. So you can still have problems with a secure design application, but it's just something you have to consider. So the OWASP top 10 is good to check your app for, but really you want to use the ASBS, the OWASP ASBS. So number 5, security misconfiguration. Application might be vulnerable if default accounts and their passwords are still enabled and unchanged. That's terribly common. Unnecessary features are enabled or installed. Like just the other day, one of my clients, it's like, why is RDP open on every workstation? When, you know, that's not necessary. Like no one needs, and it'll just be open all the time. The port will just be open for when you're on in a coffee shop, like people can just try and connect to your computer. Software is out of date or vulnerable. This is really hard to like, that's one of the best things you can do as an individual, right? Is every time you have an update, patch it immediately. But when it comes to complex infrastructure and patching is its own specific problem, like vulnerability management and patching, because there's so many you know, nested dependencies and whatnot. You know, even for upgraded systems, you know, features are disabled or not configured securely. You know, it's really unfair. You know, the offensive guys have to find one problem, and everyone else has to have no issues at all. Another common issue is error handling reveals overly informative messages to users. You can, you know, when you log in, when you try to, you know, get into someone else's account, you can see, oh, this email exists. It's like, can I reset this email? Does it tell me this account exists, or doesn't it? Or does it have a vague message that says, if this account exists, then a reset email was sent, like that sort of thing. Vulnerable outdated components, that's sort of an element of previously described. If it's vulnerable, unsupported, or out of date, definitely want to keep everything up to date. For Equifax, that breach happened because Apache struts, a server wasn't updated. The patch was released, and within 3 days of the patch being released and it remaining unpatched, attackers got in, found a configuration file, escalated privileges, and owned everything. So it's really its own organizational process issue of how you actually keep everything updated in a timely fashion. But there's a lot of solutions out there for doing that. One of the recent talks was about a software bill of materials, or SBOM, which is required for creating software for the government in a lot of cases. I think all cases now. And that requires you to actually list all of the components in your software, every dependency, like every library, everything you're importing. I mean, you don't have to show like internal information, but you like internal libraries that you've developed, but like everything external. So, and every version, so that of every component. So it's very easy to check. Oh, this new exploit came out. Are we vulnerable to this? This library was co-opted by some malicious actor, and the updates went out, or what have you. You can know exactly what version of your applications are vulnerable to these issues if you keep version control of your software bill of materials. Identification and authentication failures. Confirmation of the user's identity, authentication, and session management is very important. There may be weaknesses in the application if it permits brute force or other automated attacks. Like, are you actually locking people out after 5 attempts or 3 attempts? Are you tracking how often and where these attempts are coming from? Like, do you know exactly where your user is supposed to be? Like, there's all sorts of things that can help you keep it safe and prevent people from not coming in that aren't supposed to. So another issue is passwords. You don't want default passwords. You don't want insecure passwords. Basically, every application requires you to have good passwords, but at the same time, they say exactly what is in the secret sauce, right? It's like you have at least one character that's capital. You have at least one number. You have at least one symbol, and basically, from all the password breaches, all the statistical analysis on all of the passwords that are out there, is we very clearly see that there are patterns for how humans, at least that are creating passwords, English passwords or English speaking. What happens is, like, if it requires a number and a symbol, they put those at the end. What's the easiest thing? 1 exclamation point. So you would think that, like, well, the longer the password is, the harder it is to crack, right? So the longer it takes to try and brute force it. So you really want as long a password as possible, right? But you still will know potentially the last 2 characters. So if it requires a 8-character password, maybe it's really only 6 characters because you'll know certain things. And people can also look in breaches for associated accounts and use that sort of information of how previous passwords you've used to create better guesses. Like there's one I think Spectrum is a telecom that all their routers used to have the same format for their password, which was like a color, an animal, and then a number, and you could create that word list fairly easily and crack any router in like 15 seconds. Anyway, that's my my sell on passwords. There's all kinds of issues with knowledge-based answers, like all these things of verification. You know what you are, what you know, and what you have. Like these things that you know are essentially passwords, but so much of those questions answers is already public knowledge. Like you can look up what high school you went to with just open source intelligence. You can look up what street you grew up on, potentially, like all sorts of things. Like, and really the best advice is just using fake answers to all those things, so that even if those answers get leaked, you're not exposing anything. The last thing I'm going to say is does not correctly invalidate session IDs. If you supposedly log out at a time, that session ID shouldn't keep existing, and that's a problem for people can steal your session hijacking, and if those controls aren't in place to destroy that effectively. Second to last, software, or eighth, software and data integrity failures. Basically code and infrastructure that doesn't protect against integrity violations, where an application relies on plugins, libraries, or modules from untrusted sources, repositories, and content delivery networks. An example, which I brought up slightly before, an auto-updating app can update without sufficient integrity verification and apply malicious changes to a previously trusted application. So your library could be, like open source can be compromised. Someone can add something that and people miss the backdoor or what have you, and it gets pushed out to every single person using it, and that's an issue. So actually, second to last, penultimate, security logging and monitoring failures. Without logging and monitoring, there can be no detections, and that's a problem if you want to actually know what's happening. So threat detection and response, you can't respond if you don't know it's there. You need auditable events such as logins, failed logins, transactions. You need everything to be logged, and that's sort of the direction that security operations is going. Is log everything, get really fat pipes to just handle like all the logs coming from every single source, like your firewall, every host-based firewall, every workstation, every server, everything. Warnings and errors generate no inadequate or unclear log messages. Like you can't, like I said, you can't know what you don't know. And if you don't get logs, you can't do anything. But the other, so monitoring, just reinforcing, is core. So you have to log everything, but if you're not actually looking at it, what's going to happen? Like one of the clients I pen tested, they had a honeypot user, but no one was actually monitoring it. So like what's the point of having canaries or honeypots if you're not actually triggering alerts when those things are detected? When those things happen, when exploitation happens. The other core element is logs are only stored locally. You need to have like a cloud solution or some way to get the logs from individual devices or the application server somewhere else, so that those logs can't be immediately compromised. At least they just have to be backed up. But you want to have as many redundancy, because also if there's an investigation, if there's a real incident, you need to provide this sort of stuff and show that you've done your due diligence and that you're compliant for various regulations, depending on who you do business with. Centralized logging is pretty core to modern security operations. This is more a part of like tuning the of the alerting. So if if your security team is getting alerts, they're getting 100 events a day of like 100 isn't that much, but like 100 of the same alert triggering. They're all false positives. When there's actually a positive, like they probably won't look at it. They'll probably assume it's false, right? So you want to have as explicit messages as you can, and as accurate, because like there's only so many things you can look at a day. You only have so many analysts, and you only so many eyes on the screen. So you have to alert. You have to tune your alerting process, and also like if you don't actually have the process in place, you don't have a playbook for what you do when something happens. Like that's then you're kind of like, oh my God, there's a hacker on the server or what have you, and you don't know, you don't have like, you have to learn everything like on the fly, and it's a lot more stressful than like we know exactly what we're going to do. So I mean, a lot of cases in an organization, they won't have a specific issue. So like, oh, all the executives just made a big deal with some Middle Eastern client, and they're all going to fly out to that country, and like, well, do we want to have any more like what do we do in this case? Like, even, I mean, this is not a web application, but when you have how do you build out a program for what you do when your employees travel? Like, so you don't have to, or like, here's some malware. What are we going to do when the application server is attacked? So actually building that out, even if you haven't done it yourself, having the playbook there is a lot more comforting, because you know exactly where to look, and you can update it as needed, of course. But it definitely reduces the stress when it happens. So this is sort of the last element. If you're being tested, if you're being scanned, if you're being someone is actively hacking you, like, you want to know that. So like having penetration tests, even just running a scanner, can let you know, are you detecting things, and you can modify your alerts on that. Lastly, server-side request forgery. This is new this year on the top 10. It's basically whenever an application is fetching a remote resource and you don't validate the URL. So this can happen a lot. Like, you can send very specific requests and get a lot of unexpected results. And SSRF is increasing. There's so many cloud services, and architecture is becoming more complex. It's really hard to keep track of server-side issues. So this is another thing that's hard to explicitly test cover all your bases, but it's definitely very important. So now let's actually do things. Hopefully you have signed up for the Avatar platform. I'm just going to show their website real quick. The idea is security awareness, which is the point of the top 10 initially. Provide continuous training for developers, and basically support your security culture. So has everyone in the room at least logged in? It won't let you log in? Not on your phone, it won't.
No, but I've already tried.
Oh, really? Dang. The invite link is in the meetup.
Yeah, or do you want us to log into the avatar?
Yeah.
Okay, thank you.
So let me. So here's the invite link. There's only 99 seats, so that might be an issue, but
So, like, actually, when I start with it, can you explain about how can I go and take the exercises?
yeah, I'll be explaining the platform shortly. But what was your question?
Thank you.
Oh, so it's in the OWASP OWASP version of this, I guess. Okay. Well, I can. Okay. Can you? Can I guess I can just post this in the Zoom. Or Marco, can you post it in the other Zoom comment? The one in the OWASP group.
It's just I don't know. But I already have one.
So there's 15 people that have joined the team so far. Chats. There we go. All right. Thank you. I'm not logged in. Is everyone on the oh shit. Is everyone on Zoom logged in? I guess I can wait for Chun.
Yep.
Good to go? Or are you still typing? I believe you can get back to it. Did you complete one already? The yeah. The so the so it's a secure code learning platform. It's a training platform for developers and also just for anyone for security awareness. So I'm just let me know when you're done. Sorry to rush you. So there's all these different learning paths for any for all kinds of whatever you're looking to get better at. So there's like currently secure backend development in Python, secure full stack development, DevSecOps, backend in C#, backend in Java.
Are you showing a screen? Actually, Zach, it is showing your meetup screen. Are you trying to explain with the avatar?
Yeah, I'm not showing it yet.
Okay, no
Have
problem.
you typed it in on? Okay.
Uh-huh.
So there's a lot of different learning paths. So you can, whatever you want to focus on, you can get better at. So Python, Flask, you can join any of these things. I'm the leader, so I can assign any of these things to you. But right now, I just assigned a few modules of. So here's the here are the different modules I assigned for today. So these are all OWASP related. There's the onboarding module, which we'll go through just to learn about the platform. So I believe it's already assigned, but here's how tutorials work. Basically, there's two types of there's two types of exercises. There's tutorials and then there's challenges. So challenges are more like CTF. You don't actually get any, they don't give you the answer. Tutorial, however, is like a fully guided exercise. So they explain that here. You have to solve these by yourself and submit a flag. But there are hints. So I'm just gonna start this. What happens is it opens a Docker container. Here's the, you click on the web service and you can check solution. So this is, once you've done the tasks, it can verify that you've completed it through unit tests on the back end. So I'm just going to, so here's their Netflix. Here's the URL, which sometimes I forget, right? Which one, but here on the side is the framework for basically it'll tell you generally the direction to take if you don't know. On the side there's different examples. So here's just the website. They generally show you just the one that you specifically need for that exercise, but here is in this case it's a text file, but it can also show you code. And then here you have access to the terminal that's running this web service and the console in case you're printing anything to the console on the site. So right now we're just going to see, or it just says click one of the links. Here we're going to log in. So we're gonna try, so we're gonna try to probably break in here. But well, actually, I think this is just a tutorial example. So hello world, I'm gonna say hello. Hello, OWASP attackers. And you can see, here's the console. We're gonna see what's actually in this folder with ls, list contents, and we can cat or concatenate print example.txt. So here we see what was changed in this file is automatically updated on the server, and we can see the effect of that change by checking the server. So you can hit check solution to finish it. You do need to like close this app, this page to like once you're done, it doesn't like tell you you're done, so you have to come back.
It was the check solution.
Got it. So you can rate it, and I'm fully confident that I can do this again. So here's a second one. This is an actual broken object level authorization, BOLA, or insecure direct object reference. This is an example of the first, number 1 on the OWASP Top 10 of 2021, broken access control. So here's a recommended reading. For all of these examples, I will say RTFM, you should read everything they give you before, but I will of course answer any questions that anyone has. And don't be afraid to ask your neighbor as well. Everyone has different skill sets, so and we're all here to learn. So we're just going to see what this oops, didn't open the next page. Okay, so here, broken access control. If you ever want to know who you're working with, feel free to register and check the profile of anyone. So let's do that. Test. Username not available. Test. Don't need to save that password. So now we're online, logged in, and they'll show you online users. Noah, Francesco, Kate. So let's see for profile. They tell you the ID. Some of the stuff is exposed in cookies sometimes. It usually doesn't tell you explicitly on the page what the ID for any user is. But so Kate is 8, Bob 2. Looks like the users change every time. But in the side here, they ask, is it possible to load user profiles knowing only their IDs? So how would we check that? Or like, is there anything you notice on this page for how we're selecting, how this profile is selected? Yes. So here we can see in this web service, it's selected. We can check the user by ID. So who's 1? Is there anyone? John? Is there a 0? Doesn't exist. Is there? I believe they asked for 19.
Try admin.
So, yep.
Admin user.
You made a user?
Admin user instead of
Admin user?
yeah. Try admin.
Yeah. So I assume that since this is the IDs are an integer, that you know, potentially we could see if different things break it, you know, but generally I would assume like admin, I would assume maybe that's user 0, but that doesn't exist in this exercise. But they say, what if we change the number in the URL to 19? Easy. We get here, profile is private. But if only there was another page that shows a user's username, like a vulnerable profile page. So if we go to our profile, we see what ID we are, we see our name. But what do we see in the URL? Profile ID equals 21. So let's see, can we see another user's profile? Yes, we can. So for some reason, he posted his address. That's probably not his address and a credit card, but why an attacker would make, I mean, you would make an account to sort of go on the happy path, right? See what sort of things you can see when you're testing an application. What are like the normal actions you can take as a user? You can sort of map the entire site, and then you can start looking for stuff like this. Can you break the profile? Can you, when you're uploading your profile photo, is there any way you can, you know, upload a reverse shell into the image field, because you can, you know, you can just, you know, preface a script with BMP, or and then it will be read as an image file, but actually it's just a script that when it gets loaded from the server, it can open a reverse shell, for example. So here we see the actual code, which is, you're always authorized, it looks like, on your profile. So current user is an integer. These are type hints, which is nice in Python 3, but it's not required. And it doesn't, I don't think it actually stops you from putting in another variable type in there. But basically, what do we want to check? Like, what do we want to do? Who do we actually want to see here? We only want the current user to access a profile if it's the same ID as the profile ID, as the user ID. So what you can do is, if current ID equals ID, return true, else return false, or you can just say return current user equals ID, because if this statement will be evaluated to true if the user is correct, and it'll evaluate to false if it's a different user, and then we can hit deploy. And now when we try and load this page, there's an error. So we're not allowed. So this is, you know, this is a code snippet of what's going on in the backend. But so this is just check this. Yeah, good work, Liz. Your application shouldn't rely on security by obscurity. You shouldn't deny by default rather than allow by default. Make sure, don't even think about random user IDs as a prevention mechanism, because even with an extremely long alphanumeric string or something as your ID, that can still be guessed. But definitely not just plain integers. So that's the end of this tutorial, and we can exit here. Check solution. Oops, check solution, and let's go. So here's a challenge. Introduction to challenges. So this is one that'll give you hints, but you have to submit a hidden string that you'll find, and you'll know it when you see it. So let's start this exercise. There are 2 readings, so definitely take advantage of that. But I'm just going to show this and let someone tell me why, what the first place they would look for trying to break into this. Router. Yeah, TP link Archer C7. So what device is this actually? This is like a standard password issue on routers, like I mentioned, Spectrum routers at one point. All kinds of routers, people generally don't change the default password. And you can just look that up. So, I mean, we can look up WireGuide. Potentially, it's fake. Let's look up TP-Link Archer C7. So this is a standard router, actually real. And let's just look up a default password. So this is pretty common. That you know, if you forget, if someone forgets, they want to be able to change it, but you know, this is like a very simple issue to fix. But we see here are a few answers, probably admin. We probably could have guessed that as well, but yeah, so that lets us in. And here's our flag. Congratulations. So this is all, you know, but you can say, you know, if we're logging in instead, we can say admin and then quote, and then that will close, you know, that'll include just, or it'll end the variable, and you can comment out the rest of the line, and that's like the most common way in. But there's like a lot of different like payloads, all of the things is classic, commonly used cheat sheet for this sort of thing. So there's all these different types of databases. You potentially don't know what you're looking at, what type of database. So there's different ways to check which one you're in. So here's like the database management system identification. You can enter specific things and see what kind of results you get. For the actual, here's the classic auth bypass list. So you can just try this entire list of potential bypasses, and if they're using a block list instead of an like paired statements or something, you can potentially bypass all kinds of auth. And you can hide your characters. If they're blocking specific characters, you can code it within SQL. So here's but what we're doing right now is we can also comment out everything after the row ID. Right, that's what I was showing. Try to cause a syntax error to prove the application is vulnerable. You will see the message in the logs file. So they actually pre-type this for you. We're curling 127.0.0.1, which is localhost. It's running from the server on port 11111. We're curling the index, so that's just the main page. Where the -H is for header, connection, keep alive, content type, application, form encoded, and then we're adding this cookie here's the actual data that we're sending. Console equals 1, delete ID equals 5. So here's the actual beautiful soup of HTML we get. That's the content of this actual page. So that'll be the same as page source, or actually not the page source, the spec here, this specific part of it. But we can't. We don't have enough space on this on the window. So we see here's a new log coming in. We tried to delete row ID 5 again. Here's the cookie. It's the same thing. So we can delete anything we want now. We can delete 4, you know, as long as we change what the ID is. So now we get this other message. You can only delete your own items. So what other things would we want to do here? You can try and add something to the. What did we get last time? Was there anything generated here? No. We have this script. Maybe we need to use that. So how do we want to remove this fake item? Still don't know how to. And we can change anything.
Yeah, you can't go down into the Linux terminal and put remove.
I mean, yeah, I don't think this is the point of the exercise.
Yeah, probably not. Never mind.
So I picked a bad example. I mean, potentially it's that same issue.
The other tutorial had hints, but I'm not seeing them on this one.
Yeah, this might be a challenge. I think it says, I mean, potentially the session cookie is bad. So you can only delete your own items. Is there a way that we can change what our user ID is in this request? I don't think so. So I think it's probably just, we need to log in as the, that user. User ID. Do we have any information about this user? Oh, added by user ID 19. We have the actual URL.
Can you just try logging in as admin and seeing if you can do anything from there?
Yeah. Essentially, we can delete it from here, right? The actual delete request, right? When we add something and then delete it, we delete this. So maybe we want to say, can we
And then that the notes there says that, I'm sure you read it there, but
Yeah.
it says add and then remove a new item to generate the valid session cookie. After that, you can copy it from the log file in the terminal.
yeah, that's what we were doing before, right?
I thought so, but it's still there, you know, and all the other tutorials like give you a new little thing
Yeah.
when you finish that one. And it does say like remove, it doesn't say delete. I don't know. Sorry.
So it's all good. I mean, supposedly we're not admin, but I can try a bunch of these, you know, injections. Does anyone else have ideas or manage to crack it? I'm pretty sure, like,
Bunch of new people, welcome.
yeah. Maybe I should move on to something else. But,
Which challenge are you on? I can't- Oh, cool. Thank you.
got it. Well, let's see what I mean, they just link us to this, right?
Yeah, I looked through that and couldn't figure it out.
They show the examples, but
I guess I'm wondering if it's not adding it actually in there. But I don't want to misdirect you.
so can we actually add, what does this do? That just adds it directly. Well, I don't want to waste any more time, so we can do a different one, but this was supposed to be a tutorial.
So actually, how is this workshop we need to work on? Like, we all solve the one question or problem together, or?
No, you can work on whatever one you want. I was just trying to show off some of the
Okay.
different ones. Let's do they have some cool security breach examples as well.
Hi, I have a question. Until when do we have access to these exercises?
When do you have access to them?
No, until when?
Until next week on Friday.
Okay.
But we can start the actual competition.
Is there a way to like extend that access? This is a really neat platform. Just for,
Yeah,
like,
I was thinking.
I can ask the platform owners.
that would be so cool if you could. It's
Yeah.
really neat. And I don't know if I can get all the way through what I have access to in a week, but if not, no worries. It'd be cool to just try. Thank you.
I mean, I'll put this till 12, but I think we're approaching the end of this anyway. Or is it? Or
We're not-
I mean, I can put it till 5 p.m. today. The end of Jesus. I'm all mixed up. I mean, even 7, but
Yeah.
this is.
But aside from the CTF stuff, just like the rest of the stuff, the the modules and whatnot.
Let's put all the easy and then all the shorter ones. So these all have hints. I'll put the hints on, but and then we'll put the long hard one at the end. And then I think there's 3 in a row that I did the sadness. Can't filter on that. Okay.
Thank you so much.
Okay. Is there? Well, I do want to be able to announce it before the end of the day, so maybe I'll just say till until 1. Yeah, for some reason, as the leader, they don't keep track of my progress.
We know you're good at this,
Supposedly.
except when everyone's looking, which is always
Yeah.
the case.
I'll go through the clickjacking. So clickjacking isn't actually that common, but today, but you know, it can be a part of more sophisticated stuff. Where a user is tricked to click on something different from what they're expecting. So let's see. The attacker creates a page that contains a site in a hidden iframe where the victim is already logged in. The victim thinks he's clicking on the attacker page. However, he's clicking in the invisible iframe and executes. Notify. Profile. So we can delete the profile. So here is the clickjacking site. So this is a common thing where they'll just show you the same page that you like to log into something that you're already logged into. That's a very common thing on like Facebook exploitation too. It's like you click on a link that was sent to you that was a scam, and then it'll take you to another page that looks exactly like Facebook, tells you to log in to see the stuff, and then people will just do it. So here, let's log in again. But missing user, how did that happen? The user profile has been recreated to check the attacker page without hiding the iframe. So let's look at the attacker page. So there's an opacity issue. Yep, web ID. So there's an invisible opacity 0. This element is invisible. The style for so the reason why clickjacking isn't as big of an issue is you can prevent it with simple fixes, but let's see, where's their app? So now we just deny the external options. actually. So there's an invisible iframe, right? That's that was placed over it. And so when you click the link, it just was actually clicking the delete. But deleting your account is a very odd thing to clickjack to do. Anyway. So this is another insecure profile access. We could do that one. Let's do hashing and password cracking. So for those that don't know, hashing is like a one-way function where encrypting, you can decrypt it afterward. So generally, the only way to figure out what the original string was that was hashed is to run a bunch of different strings into the hash function to try and get the same hash as the existing. So let's see, we have a zip file. Yeah, there's two ways right here. Rainbow tables, pre-computed hashes. You can check those hashes against what you have. Brute force, you can just try a bunch of passwords and push them through the hash. So MD5 is not secure, but still useful for getting files, for identifying files or processes, for malware checking. Python 3, MD5, and then here's the cache here. This, we're hashing it again. So to prevent needing to prevent like the rainbow table attack, you can add salts to your passwords so that the hash will be different than than the actual password. So you can't just run the password through the hash to get the answer, but the salt is usually stored locally, so it's if they have access to the passwords, they can see what the salt is. So this is still more effective than just hashing, but it's just one more step. So let's see. You can crack it. We're just saying hash salt. I mean, it should only take slightly longer, like very, very slightly longer, because you're just concatenating the salt to the hash, but salt to the password. But it depends on how it's actually implemented, like you put it before or after, in the middle or something. But it has to be done in the same way, because if it's not, you can't verify that the password coming in and the password that already exists are the same. So let's just go through BBFJ. Raising it might make the login process too slow, but the longer it takes to actually compute the hash, the longer it takes for someone to crack it, right? So that's the issue with quantum cracking is supposedly, right? We can take the amount of time, the amount of iterations essentially down a lot. But there is quantum safe cryptography. that exists, but it just takes longer. So I mean, like theoretically, if we're encrypting or hashing, well, I guess I mean for encryption, quantum safe cryptography, but for hashing, like potentially you could just make it take a really long time, but quantum computing is able to crack it faster, I think. Let's see what we have. So this is a hash. You see these a lot, but we can look this up on Google. Google. Let's see. Does anyone know the password to this one? Did it let me in? No? I didn't try password, but usually Google is really good about that. I don't know why this isn't working this time. It's not what? How did you find it? Is it just Googled it? Why this is so God damn it, Bing. Yeah. I did say try Google, so that is the problem. Anyone know what that is off the top of their head? Top row, or all the symbols, shift, cross.
A trick
All right,
question.
well, sorry?
Is that a trick question? I'm like, I don't know what that is.
Yeah, I mean, you just should be
So shift and hit
shift
everything.
1, 2, 3, 4, 5, 6, 7, 8. MD5 is really uncommon now for password hashing, but
Because you can get the answers on Google.
yeah, I mean, there's issues with collision with MD5, even where like two different passwords could potentially turn into the same hash, which is definitely a problem. But it's still like extremely rare, and it's also a very quick hashing issue. So or a hashing method. So if you're trying to hash like a file to verify integrity, that's generally okay. Like if you check virus total, like it will it'll turn into a SHA hash. See, this one isn't actually a file or a process, but it's that's kind of the way you would check if a file was what you thought it was, or if it matched something else. Like that's also what happens in like police databases and whatnot. It's like, does this file exist on this other person's computer? Can we correlate? This person definitely sent this thing to this other person and prove something happened. So this is, I think this is about it. You're free to continue to do the exercises until next week, and the CTF I'll call it at 1, and I'll let everyone know when what the who the winner is. But I'll just walk around, see if I can help with anything. But yeah, for a week. So there's other platforms like this, similar but not. This is the only one I've seen that does this whole experience of you can see the web application, you can exploit it, you can then see the files, you can see the file system, the all these different elements. You break it and then you can learn to fix it. Like there's other platforms like Secure Coding Warrior, but that one is more of, you don't actually do any coding yourself. It's like this is the topic. We're talking about this specific coding language. Here is an example application. Here's all the code. You don't get to see anything, but it's more of like a teaching you code review, and then you have to identify like what the different what it is, what the problem is, how to fix it. But it's more of like clicking from a drop-down list rather than actually doing anything yourself. So I prefer this one. It's definitely pretty sleek, but and I'm saying this as someone that won a Secure Code Warrior competition at one point. So until 1 p.m. So yeah, I think that's when lunch happens too. But
So after that, will this avatar available for me to try and test the like exercises and challenges?
yeah, so Avatar is generally for is sold to companies for training their employees generally.
Oh, okay.
So you can try exercises. You can but really it's in another conference or in like a CTF is probably the next time you can access it individually unless your company buys it.
Oh,
But,
okay. But now actually I'm on a different time zone. I'm not in the CST. So in case if I like run very late, so is it okay for me to follow up your discussions that what you are discussing in this in the meeting now, and then I can try the exercises later?
yeah, you can try it. You can do the exercises for a full week. It's just the competition ends at 1 p.m. today,
Oh, I
Pacific
see.
time.
Oh, I see. I see. I see. I get you. Yeah, no
Yep.
problem. Thank you.
Yeah, no problem. So I think unless anyone on Zoom has any other questions, I think I can end the talk here. More of an overview of the tool.